Then I'll just start because I have the first part anyway. So hello to everyone who's listening to this. So this is a short presentation about the result of our analysis on the City Nature Challenge, where we're looking at the dynamics of citizen science. And yeah, so I have a short overview. So who are we? So we are a project team from Correlaid, which is a platform that connects volunteers with data science skills with nonprofit organizations to help them with data science tasks like this one. So there are different, it's a big organization and there are different projects, and for each project and each NPO, there's a team that's getting assembled for that. So these are the people that are part of the City Nature Challenge team. And yeah, and some of those will present today, and many have contributed different individual results. So I'm going to start and show off some of the analysis that I did. First of all, then what did we study actually? So what we're looking at is the observations that users make on the iNaturalist platform during the City Nature Challenge, which happens in different years in different cities. We've been looking at observations made between 2017 and 2020 in the cities of London, San Francisco, and Los Angeles. So we've downloaded data from the iNaturalist API and analyzed it. And the data we've downloaded is observations made by users. And with each observation, a lot of data regarding the observation. So which user made the observation, where it was, when it was made, which species was examined, and so on. So there's a lot of data contained, and we kind of delved into that and looked at a lot of different aspects of it. So, so first off, we've looked at some general statistics of the observations and at the users that make those observations. So one thing we looked at is how did the participation change over the years? So here on the left, you can see the users per year. So you see that we have a couple of 100 or 1,000 users in each challenge, in each city. We have most users in San Francisco and Los Angeles, and London is a fairly small in comparison. But overall, the number of users has increased over the years. One interesting thing is that what we do see is that the number of observations has also increased over the years, but the average observations per user has decreased over the years. So these newer users that have joined in the later years, they have contributed fewer observations on average, or the total number of observations per user has gone down. So one thing that we're exploring is whether we can classify the users by how they participate and depending on how many observations or identifications they do. So users can submit observations and then other users can identify these observations. And users differ in how much observations they contribute versus how many identifications they contribute. So we've come up with this broad clustering where we say that users that contribute few observations and few identifications, these are like low activity users. And then there are groups of users that either contribute a lot of identifications or a lot of observations. And then there are also users that contribute both, a lot of both. So one thing we're looking at is like, yeah, this is one possible avenue of how one can distinguish these users, and we're looking at is their behavior on the platform different. So, and another thing we're looking at is how the users change over the lifetime of the challenge or between the years. So one thing that is interesting for the people that organize the City Nature Challenge, which we got as feedback, is, for example, what makes new users stay. So new users that come into the challenge, what makes them stay in the challenge, what makes them participate more on the iNaturalist platform, or what makes them leave also. So one thing that I've looked at, for example, is I've analyzed the users that join in the City Nature Challenge in 2019. So that haven't been users before, but then they're contribute observations in 2019. And then we can see in 2020 whether the same users will stay on board or whether they get lost and they don't participate in the challenge, which means they might participate later on or in other, not in the City Nature Challenge, but yeah. So that's interesting to look at if you want to see, so what makes the users that join in 2019, what makes them stay also in the later year. So one thing we found out, so this is a table of just the number of users and the number of users that are onboarded and the number that are lost. So for example, in London, a total of 722 users participated in 2019. And of those, 528 were new. So they haven't participated in 2018. And that's actually a large, quite high number. And it's very similar for the other cities too. So there's a lot of turnover in between the years. And then if we look at these new users in 2019 in more detail, there are 103 of them that are onboarded effectively, so that stay also, that contribute also in 2020 then. And 425 of those don't contribute in 2020. So approximately 15 to 20% of all new users that join in 2019 for the first time, they also participate in the year afterwards. So, and then it's interesting to see like what makes these users participate in the later year, or how does their behavior differ? So maybe can we say, can we detect which users will participate in the later year? So one thing that's interesting is if we look at the average number of observations per user. So here we see the observations per user in 2019 and in 2020. So we have one bar for all users, all new users that, or all users that participated in this year. And then also the average for the onboarded users that will join in 2020 again, and for the lost users. And what's interesting is that the new users, and generally they make fewer observations in the first year in 2019. So they are below the average, the all user contribution. But what's quite interesting is that in 2020, the onboarded users that stayed in the next year also, they make more observations than the average user in 2020. So it seems that new users that join, they're quite active also in the following year. So that's one aspect, and we're also digging deeper into these things. Yeah, and now I'm passing on to Vadim, who will also show some results.
Hi. So yeah, here's my addition to this analysis. I know I call it attrition. I'm not sure that in this case it's suitable term, but I think it also can be applicable to attrition of iNaturalist users. So here I bit extend the analysis of Frank. I'm looking how these attrition dynamics work, not only in regards of challenges, but also how does it change from 1 month to another. So for that, I bit extended our data set. I collected whole data for San Francisco for 2018 and 2019. And I looked for how many months new users stay on the platform after joining it. So for instance, if we look at the January, here, both charts, they present 2019. And for instance, if we look at January 2019, we can see, so x-axis, it presents for how many months the user stayed after joining platform. So as we can see that 0 months, it's the most, it's the highest value for all charts. It means that the user just joined the platform for 1 month, and after that, he or she stopped using the platform. I was thinking that probably it would change in the months of challenge in April, probably April, I know, like probably people who took part in this competitive challenge, they would be more involved in the following activities or something like that. But I didn't find these patterns. We can see that it's quite similar for all months, especially we can see it on the chart with percentages, the right one. So we can see that the most of users, the majority of users, they stop using the platform after the first month. But at the same time, we can see that there are in all months, there is like minority of people who stay like for 4, 5, 6 months. I think that one of the the future directions, and Frank mentioned it, it would be interesting to focus on these people, like what exactly, I mean, it can be done just by comparing those people who stopped using platform after the first or the second month, just excluding those who stopped using it after. Uh, I think we should exclude those ones who joined platform and after that stopped using it. So this blue bar, and I think it would be interesting to compare those ones who stopped using platforms after like 1 or 2 months with those ones who who stayed on the platform for a longer period. I think it's one of the interesting potential directions for this research. Yes, so and another, can you change the slide? And the next one. Yeah, and another area that I find quite interesting is clustering of users based on their taxons that they were collecting for iNaturalist. So my intention was to somehow identify specializations of users. So groups of people who are focused on collecting only birds, some people who are collecting only flowers and plants. So far, it's still this part of the research is still under development. I'm still improving my way of clustering users because it was a bit more difficult than I expected. So yeah, I was clustering users based on the orders of taxon that they were collecting. And one of the potential application of this is personalized recommendations for the users. For instance, if we know that the user is specialized on collecting taxons related to one of the order, we can recommend this person some special territories in the city where he or she is collecting these taxons or something like that. Yeah, and just 2 examples. Like the next slide presents just one of the clusters. It's cluster one. One of the specific features of this cluster, so far it's only about San Francisco. I need to mention that these people are more interested comparing to other clusters on some taxons that are related to like water, who live in the water, like some plants and I think some animals. So, and we can see that depending on this interest, the like these scattered points on the map, they are also highly related to water. So many objects they were identified in the water areas. And the cluster two, just example cluster. Next slide. Yeah, here, I mean, even on the map, we can see some other patterns of collecting taxons. So these people are mostly interested in some flowers, and they can see that how, based on this interest, the locations where people are collecting these taxons, it also changes. So, for instance, the water spaces, water areas are not so covered, like comparing to cluster one. So yeah, just 2 examples how we can identify some specializations of users and also find how the patterns of collecting these taxons in the area, how it's dependent on these specializations. So yeah, that's all from my side.
Cool, then I'll take over again. One thing we're also looking at is the social network of users. So we know which users make observations and which one identify them. So we can look at like which users interact with which other users. And so examine the social network of it. So one way we create the social network is here on the left. If we have a user A who makes an observation, and then there are other users who make identifications of this observation and add species, help identify the species. Then we can say that each of these users interacted with the user A once. So this is one way to create a social network from all these users. And this is an example of how such a network looks. So this is the social network for the London 2018 challenge. And the colors here, they denote the clusters that I showed earlier. So these are like the generalists and then identifiers, observers, and low activity users. And there are many interesting things we want to look at, and we're pretty much in the beginning of analyzing this. So for example, where are the different types of users in this network? For example, it seems like that the observers especially are very central in the network. Or we also want to look at the user attrition and where these onboarded or lost users are, for example, in this network, and whether we can see how active a user is going to be on the platform depending on where in this network the user is situated. And so, yeah, the question is, can we use their position in this network to distinguish the users? Which users are most central or most popular? And also if there are distinct communities of users that tend to interact with one another more than with others. For example, one could imagine that users that look at water species, that they form such a community. And yeah, so we're in the early stages of looking at that structure. Okay, and then another big topic we've been looking at is spatial patterns. So where do users make observations? So I'll hand over to who made this slide.
I focused on the patterns of the observations, so namely distributions and clusters. And here we can see that with years, the distribution of the observations actually increased. And London is a really good example for that because it's really evident there. I mean, it's also the case for the other cities, but there it's not so explicit as in London. Another interesting point is also that it can happen that some places which weren't so important in the beginning become more important with time. In London, it's the case for the Epping Forest, where we can see that while in 2018 there weren't so many observations, in 2020 it's actually the place with the most observations. And also looking at the next slide, please. So looking at the credit count, we also can see that the outer regions become more important with time. So in the beginning, the center was like the most important place, and it's still one of the most important places. But with years, the observations in outer regions increase as well, but not proportionally. So some outer regions have a relatively higher increase in observations than others. And which is another interesting point is that due to COVID, it's not like really evident in London, but it was more evident in other cities. But here, for example, we can see also some cases where outer regions had actually less observations in 2020 than 2019. That might be due to COVID, where the travel distance was limited due to the restrictions. Another point I looked at was clustering of observations. Frank, could you switch to the next slide? Thank you. So therefore I calculated the Ripley's GD function, which basically calculates the distance between a point and its nearest neighbors, and looks at the proportion of points within a certain distance, and then compares it to a random spatial distribution. And if the increase is more rapid than the increase of the spatial random distribution, then there's evidence for clustering. And here we can see that it's actually that we have a more rapid increase. So there is definitely evidence that the observations are indeed clustered. Yeah, that's from my side.
Then I'll go next. So what we also did was that we since each observation in the dataset that we got from iNaturalist has or comes with a GPS coordinate, we retrieved the green space coordinates of each city from OpenStreetMap, and we gave each observation a flag saying if the observation was made in a green space or not. Green spaces may be, for example, parks or forests. And I'm just displaying London in here because we still have some issues trying to find the right green spaces for San Francisco and Los Angeles. But what you can see in London over the years 2018 to 2020 is that in the years 2018 and 19, observations are nearly equally distributed between green spaces and non-green spaces. But in 2020, which is the green bar, you can see that most of the observations were made in non-green spaces, which may be due to the COVID-19 pandemic, because parks were closed because of the restrictions, and people were not able to travel that far, so maybe not able to travel in forests that lie farther away from the city. So yeah, this is one thing you can see. And then Frank, please go to the next slide. So another thing that we looked at was how many users did at least 3/4 of their observations in green spaces. And here you can see all 3 cities, but still the numbers for Los Angeles and San Francisco may not be right at this point, since we still have some issues. But we can look at the numbers from London, and we can see that in London, like from this point or at this point, the users tend to do the biggest part of the observations in green spaces more often than in San Francisco and Los Angeles. But we are still not sure if this is due to the fact that there may be substantially less green spaces in Los Angeles and or San Francisco, or if it's due to the fact that we still have some issues with the green space labels. So yeah, the next slide, please. Another thing that we looked at after the exchange we had with the organizers of the City Nature Challenge was to look how the green space distribution changes over time. So here this plot is for London again, and on the x-axis you see the different days in 2018, 2019, 2020, where the City Nature Challenge took place. And on the y-axis, you see the proportion of observations made in green spaces, which is in green, or in non-green spaces, which is the orange bar. And something really interesting you can see here is that, for example, for 2018, on the 29th of April, you see that the bar or the height of the bars changes. So whereas on the 27th and 28th of April, most observations were made in non-green spaces, this is not the case for the 29th of April. And something pretty interesting is that on this exact date, there was a CNC, so a City Nature Challenge event in the Hyde Park, which is a green space. So probably this event made people do more observation, or led people to do more observations in green spaces. And again, we have the same phenomenon actually in 2019, where there are substantially more observations made in green spaces on the 27th of April. But I couldn't find any event for this, searching for it in the internet. But probably there was some event as well, which led people to do more observations in green spaces as well. And something really interesting also is that in 2020, overall days of the City Nature Challenge, most of the observations were made in non-green spaces, which may again be due to COVID-19 and the pandemic restrictions. So yeah, that's it from my side. Albrecht, we can't hear you.
Albrecht?
Yeah.
Yeah. Still not, unfortunately.
Now it's better,
Yes,
but it's like
it's
I
good
can
now.
hear myself. Okay, then no, maybe. How is this one?
Now it's worse. Now there's some buzzing. Now it's okay again.
Sorry. Okay, let's go for it.
Okay.
So can you play? Please?
Yes.
And maybe full screen. Right. Yeah. Thank you. Yeah. Now you can visualize the spatial analysis with the help of this interactive map. So up we see the observations for 2019 and down the observations for 2020. So before and during the pandemic. So the number of observations in 2020 is less than 10% bigger than in 2019. So you can compare both years very well, but you do see very different patterns. So up here, we see in 2019, the distribution is very concentrated in the city center, like with few clusters and many observations in them. And in 2020, you see like the distribution becomes very like scattered, and you have like many clusters with few observations. Like also if you zoom in, you can still see that very well. Like in 2019, you have like, you know, very concentrated, and 2020 becomes very scattered. So yeah, that's like Anna and Florence said, like probably because of less travelers in 2020 due to COVID and restrictions. And that could also explain very well that people avoid like the green spaces to make the observations. Like you see the Hyde Park here with 700 observations in 2019, and it's almost disappeared in 2020. It could be also that the Hyde Park was closed, I don't know, but that's definitely correlated with the COVID restrictions, and that's also true for the other green spaces. Yeah, that's it for my side. Thank you.
Okay. Let me just exit the video. Was that it? Are we at the end?
Yeah, I think so.
Okay,
I think
cool.
this slide was from Lyubov. So
Okay, cool. Yeah, so these were some of our preliminary results. We're gonna keep on researching, and we're also gonna present some of our results on an upcoming conference, on the CitySci virtual conference in May. We're gonna present a poster there. And yeah, I hope that was informative. If you have any feedback or any questions, well, I don't know how you can reach out to us. Probably we are the City Nature Challenge organizers in some way. Yeah, cool. I think that's it from our part for this. Muki, do you have anything to add, or anyone else?
Excellent. The whole presentation was great.
Okay, great. Well then, thanks everybody for joining and contributing. And yeah, that's it, I think. Cool.
cool.
Okay.